Good afternoon. Today we are starting our Unit 8. We are working on PO46, so right from the get-go, the beginning of our unit is a power objective that is super important to know. I can create a function table for a given equation. So in order to start this objective, we need to know the terms that go along with a function table. Input is what you plug into an equation, what is being tested. So it is the number that we're plugging into a variable. The output is the result of the equation or test. So you put in a number into a variable, you do the math, and it equals something. That is our output, what it equals. So the result of that equation. So the function table is a way to organize all the multiple inputs and outputs to get ordered pairs for a graph. So usually when we have our function table, the equation that we use for that function table, we call it the rule that we're going to follow. You're going to plug in a number into that rule, and what you get out of it is your output. So we have the X and the Y because we're going to be using it to graph. It's going to give us ordered pairs. So our input is our X and our output is our Y. So that's how we get the ordered pairs that we use to graph. So the equation we get from a function table is known as the rule of the table. We're going to create a function table with at least 4 inputs or outputs for each equation given. And you're going to see a pattern. Just like in our math packets, when we do the logic pages with the pattern, not the logic pages, the pattern pages, when we have the different figures, and we say, oh, we need to do the blue blocks, the yellow blocks, and the total for our table, and you can see how a pattern develops. Mr. Schultz always gives us 4 figures to start with. So you can really see what the pattern is. It's the same thing with function tables. 4 is going to show us a good pattern that we're going to be following. This is important. Remember that you can choose the inputs for your table. So we're going to want to choose smart ones. And I'm going to show us what that means to choose a smart one. Most tables, it's not a big deal. There are certain tables that we really want to pay attention to because we want to make smart choices so our X into the Y's is a lot easier for us. We don't want to overcomplicate our lives. So I'm going to scroll up. Let's do some samples together. It says we're going to make our function table for each of these equations. So to make a function table, we start with our X and our Y at the top. We need 4 inputs. So I'm going to give myself space for 4. You could close off your function table if you want to make it a full table. I typically forget to put the ends on the sides. Yes. So that's a great question. Do we just pick random numbers? Yep. What I like to do, because my brain works so much better to be organized, I like to pick numbers in an organized manner. I could just say, hey, let's use 1, let's use 10, let's use 15, and let's do -5. It doesn't have to be in order. I like it to be in order. I also like to use smaller numbers because it's easier to graph smaller numbers. because we know our end product, we're going to eventually get to graphing it. So I like to do smaller numbers. Of course, you can do bigger numbers because it's going to go on a graph, and graphs go on forever, right? We can use huge numbers. It's just not going to be easy to graph those. So here's what I would do, just to keep my life simple. 1, 2, 3, 4. I'm going to do that for my x. Remember, the x is the input. That's what I'm putting into my equation. So I'm going to put the 1 into the equation, and I'm going to say 1 plus 3 equals 4. That is my y. Y equals 4. So then I'm going to do the same thing with 2. 2 plus 3 equals 5. 3 plus 3 equals 6. 4 plus 3 equals 7. Once I've done it 4 times, I can see my pattern, right? When my x increases by 1, my y increases by 1. So I can see that it's following the pattern. So that's why I say I like to be organized. It's my way of checking my work. Is it all in the pattern? If I do just random numbers all over the place, I can't see the pattern. So I do numbers in a row so that pattern really shows up. It's my way of double checking. It's not wrong if you did 0, 10, 5, 13. It wouldn't be wrong. We just wouldn't see a pattern. Okay. Important to keep in mind when we're doing these function tables, you will get negative numbers in there. So this is negative 2x. If I do my 1, 2, 3, 4, if my input is 1, what is my output? James? Negative 2. Because this is a positive 1 times a negative 2. 1 times 2 is 2. Positive times a negative is a negative. So keep in mind those negative numbers are important. If I put a 2 in there, what is my output? Negative 4. If I put 3 in, what is my output? And if I put a 4 in? And we can see I did a pattern for my x's, so I can see that pattern with my y's. When I increase my x by 1, my y's go down by 2. Negative 2, negative 4, negative 6, negative 8. It's my way of double checking. I've got a pattern for the x, I've got the pattern for the y. Oh yeah, we're getting there. So our function tables can be a little more complex. We look at this next one. If I did 1, 2, 3, 4, I put 1 in for the x. 5 times 1 is 5. Then I have to remember to subtract 8. I can't just say 1 times 5 is 5 and put 5 for my answer. There is more to the rule here. There is a minus 8. So I have to do 1 times 5 is 5. Minus 8 would be what? If I put a 2 in, what is it?
2.
3?
7, 2.
If I put a 3 in for 5, what is my answer going to be? Sorry, if I put a 3 in for x, what is my y going to be? It is not going to be, oh, it is. 3 times 5 is 15. 15 minus 8 is a... I was writing down what people were just shouting out. Uh-oh. Do we see a pattern right now with 3 of them? No. So we made a mistake. This is why I like to be organized. So I can see when I make a mistake, what mistake did we make? If I put 2 in for x, that's 10. 10 minus 8 is not negative 2, it is 2. So just because I had negative 3 doesn't mean it's going to be negative 2. It's going to jump all the way up to a positive 2, then a positive 7. Now if I put 4 in, 4 times 5 is 20. 20 minus 8 is 12. What is my pattern for my y's, James? It's increasing by 5 every time. So there is a pattern there. So if you don't have to, but if you do stay organized for your input, you will see that pattern in your output. And you can catch if you make a mistake. What's your question, Emily? So if I have 5x minus 8, and I put a 3 in, so that's 5 times 3 minus 8. 5 times 3 is 15 minus 8. So let's look at our next one. Got x and y. I'm going to keep with my 1, 2, 3, 4. If I put 1 in for x, what is my y going to be? -9. 1 squared is 1 times 1, which is 1. 1 minus 10 is -9. What if I put a 2 in? 3 and 4. Is that right? I am not seeing a pattern here. Uh-oh. I did just find a pattern. Chance found the pattern. See if you can find my pattern. -9, -6, -1, 6.
It goes up by
Tegan, what's the pattern?
-9 minus 6 is like -3.
Okay.
And then that is
So we're going up by 3.
and then you double that and then you.
So to go from -6 to -1, you're going up by 5. Going from -1 to 6, you're going up by 7. So you're increasing by increasing those odd numbers going up. It's not always a same that we're increasing by. We increase by 1 every time. This one, just like with our patterns that we do in our math practice, you have to find what that pattern is. It's not always super easy to see the pattern right away. Now the last one, somebody looked ahead and said, ooh, we've got fractions in here now. Now it gets a little more complicated. Now is when it becomes important to choose smart x's. What do you think would be a smart input if I'm multiplying by 1/4? So what's 1/4 of 25? Can you tell me real quick? No, that's not going to be an easy one. So the variables we want to choose are going to be ones that are going to be easy. What would be an easy one, Tatum? 4. 1/4 of 4. Can you tell that to me right off the top of your head? What's 1/4 of 4? 1. Because 1/4 times 4, we put a 1 on the bottom, becomes 4/4, which is just 1. It gives me a whole number. Can I then say 1 plus 7 and get an easy answer? Yeah, I don't want to mess with fractions. I want to use those multiples of 4 that I can multiply that fraction 1/4 by and get a whole number. So if I put in, let's use plus. If I put in a 4, that would be 4/1. So that's 1. 1 plus 7 is 8. What do you think I should use for my second input? Because 1/4 times 8 equals 8/4. 8/4 is 2. 8 divided by 4 gives me 2. Now I can go and say 2 plus 7 is 9. Now, could I have gotten a fraction and added it to 7 and said 7 and 1 or 5/3 or whatever fraction it is? Yep, but would that be easy to graph in the long run. It's not so easy to graph fractions and be precise. It is a whole lot easier to graph whole numbers. So we want to get in the habit when we see those fractions of using inputs that'll give us whole numbers for our output. So what should I use as my next input? Tatum? 12. Because if I'm looking at my multiples of 4, 4, 8, 12, so I would do 1/4 times 12 gives me 12 fourths. 12 divided by 4 is 3. 3 plus 7 is 10. What should my last one be? Chance? 16. 1/4 times 16 gives me 16 fourths. 16 divided by 4 is 4. 4 plus 7 is 11. So when Mr. Schultz puts on there, be smart, choose smart inputs, he's talking about looking into the long run. What numbers are going to be easy for us because we know we're going to be graphing. Put them in order. You don't have to, but get in the habit of putting them in order so you can see your pattern and catch mistakes that you make. If you look back at it and say, well, I don't see a pattern here, maybe I did my math wrong. Especially with those negative numbers, it's really easy to make simple mistakes. When you're working with fractions, you multiples of the denominator. So you can divide down to a whole number and add or subtract easily. Does that make sense?
Yeah.
Okay, let's look at some of our work for today. After a week of timing yourself during your morning run, you discover that you can run 4 miles per hour. Let H represent the number of hours you run, and D represent the distance you run. So hours is H, distance is D, right? So now we need to decide what's the input.
Are we saying they have like superhuman endurance?
No,
So they're gonna get scored, they're gonna keep going four.
it's going to be, you're going to be at a consistent. It's going to be consistent. You're not gonna run the first hour and then go slower the second hour. We're just gonna stay with consistency. Is this real life? No. Okay. Shh. We need to know how to set up our tables. So just because we're saying the hours aren't going, you can't, this is theoretical. Just like with the probability, we did theoretical probability and then the experimental probability. This is the theoretical side. Then experimentally, some people will be closer to the theoretical, and some people like me, if I was doing this running one, I would probably really fall off, right? So this is the theoretical. So I'm timing myself running, and I want to see how far I go for my time that I run. What do you think the input is going to be? Is it going to be the hours that I run or the distance that I go?
Hours.
What do you think, James?
It would be hours.
Why would it be the hours?
Because that's the thing that you put.
That's what you're putting into it. Today I'm going to run 1 hour. Tomorrow I'm going to run 2 hours. That's what you're putting into the equation. Then I'm going to see, what do I get out of it? How far am I going to go? So that's going to be my output. If I run for 3 hours, I will go this distance. So what I'm putting in is the hours, and then I see how far I can go. So that's my output. So now I need to write an equation, that rule, that relates the input to the output. So after a week of timing yourself during your morning run, you discover you can run 4 miles per hour. So what would my equation be, Gus?
Y equals x times 4. Yeah.
Yep. It's the same thing, I just flipped it to be more algebraic. So that y equals 4x, except I'm not going to use x and y. So they told me which variables to use. So what are the variables I'm going to use, Evelyn?
D equals 4h.
D equals 4h, because my input is my x, so that's my h. My output is the y. So I don't want to write it with x and y's right now. I want to write with my hours and distance. So my output is my distance. That's going to equal 4 times the hours. So we're going to create a function table that will show how far you were running: 3 hours, 8 hours, 12 hours, and 20 hours. So they're telling us hours is what? Input or output? Input. So that's always going to be on that left side. Our first number is going to be the hours. Input is always on the left. Output is always on the right. So we have 3 hours, 8 hours, 12 hours, 20 hours. Is there a pattern to my input? No. So are we going to see a pattern in our output? No. So we know our equation is D equals 4H. So if my H is 3, what is my D? 12. Because 3 times 4 equals 12. Now I'm going to put the 8 in. What is it? What's my output going to be?
32.
32. Yeah, you can just say it. If I put 12 in for my input.
48.
Say it again.
48.
48. And if I put 20 in? 80.
90.
So now we're going to look at that table and we're going to answer another question. How long will you need to run to go 62 miles? So now they're saying our output is 62. Our distance is 62. So what's my input going to be? How many hours is that? How do I figure that out, Emmeline?
How do you do 62 divided by 4?
I'm going to put the 62 into my equation for my distance. And we know that equals 4h. What I want to find is how many hours. So what is the opposite operation I do, Emmeline? Divide by 4. So Emmeline, what is 62 divided by 4?
15.5.
So I need to run for 15 and a half hours to get 62 miles. Okay, so that's my first question. How long do I need to run? Now there's another question. If you burn 250 calories per hour of running, how many calories will you burn? So if I run for 15 and a half hours and I'm burning 250 calories per hour, what math do I need to do, Evan?
I was asking if the green's going on the B question.
This is my answer for this question. How long will you need to go? How long do you run for 62 miles? So now I want to do my second question. How many calories will I burn if I do 250 calories, burn 250 calories per hour, and I'm running for 15 and a half hours? Tatum, what's my equation? What math am I going to do? Yeah, I'm running for 15 and a half hours, and I'm burning 250 calories per hour.
3875.
Oh, Michael, what's the answer?
3,880.
3,875 calories I will burn altogether. So this is a 2-question problem. I should have 2 answers. Still talking, still teaching. When we're doing multiple steps like this, and we have multiple answers, you're gonna circle each answer. You're gonna make sure to label your answers, so we know which number goes with which. On the test, you're gonna always make it easy for the teacher to be able to read your mind. Okay, if you just have a whole bunch of numbers everywhere, I am not gonna wanna take the time. I am correcting 25 of your tests. I'm not gonna wanna search through, where's the answer, where's the answer, where's the answer? Do me a solid and circle your answers and make sure they're labeled so I know which one answers which question, okay? Always be clear, because if I can't read the jumble of numbers and I don't know what's going on, I'm gonna mark it wrong. Unfortunately, I actually have a life outside of school. I can't spend all of my time deciphering all of your scribbles. Sometimes I can figure it out easily. Sometimes I have friends that are really messy. Be organized and circle your answer for your teacher. So let's look at our second page. So we have 3 pages today. We've done the first. Let's do the first one on the second page here. Let's see if you can figure out what goes where. You pick up a summer job. Mr. Schultz started working when he was 14. I started when I was 15. He started before me. That pays a base salary of $500 and an additional $9 per hour worked. So we're gonna let H represent the number of hours you work and M represent the money. So H is hours, M is money. What is the input? What do you think, Evelyn?
Hours.
Yeah, your hours. You have to work so many hours to get so much money. So what you're putting in is your time working, your hours of working. What you get out of it is your money. So now we need to write an equation that relates the input to the output. So hours is H, money is M. What equation do you think we should have, Aiden?
Hours equals money.
So we don't want to forget this part of our equation. There's a base salary of $500. So everybody starts with $500. And then for every hour you work, you get $9. So it's going to be a little more complicated than what you were thinking. So let's make it a little bit more complicated. James?
M equals 9H plus 500.
So everybody has that $500 to start. So that's why we add $500 onto it. That's what we're all starting with. So we always add 500. Then for every hour we work, we get $9 more. So 9 times H. Add the 500. Does that part make sense?
Yeah.
So when we're doing these word problems, they're not super easy peasy lemon squeezy. We have to stop and think. What are all the components to it? Is there going to be adding or subtracting? Am I multiplying or dividing? Sometimes our rule, the equation, is just simple like 9H. Sometimes we're adding or subtracting from that, like the plus 500. So you really have to concentrate and look at what our problem is telling us. So now for D, we're going to create a function table that will show how much you will earn after working an hour, a day, a week, and a month. So we're going to want to put all of these into the same format. So if my input is H, what do I need to convert my days, my weeks, and my months to? James? I need to convert them all to hours. Oh my goodness. Yes, it is a math, and we use our big, beautiful brains in math class. So, good thing this is the one I chose for us to do together. So if we stop complaining, we can get through this. We know that we have 1, 2, 3, 4 inputs. So I need 4 spots in my function table. Is an hour easy to put into my function table? Yeah, I'm gonna put a 1 in. Now I have, oh, he even tells us 1 day is an 8-hour day. I only work for 8 hours. Goodness knows I could not work from sun up to sundown on school and do that every day and be sane. I need a break from school just like you need a break from school. We work 8-hour days. So if we work 1 day, it's 8 hours. Now I'm working a week, which is 5 days. Monday, Tuesday, Wednesday, Thursday, Friday. How many hours is that? If I work 8 hours a day, Priya? 40. 5 days
5 times 8.
times 8 hours a day. Shh, James, he's got it. Okay, so now I'm working a month. I know a week is 5 days. So a week is 40 hours. And now a month is 4 weeks. So how many hours am I working in 4 weeks, Chris?
24.
How did you get that, Chris?
I did 4 times 7,
Okay, so I'm gonna ask, why did you do 4 times 7?
because there's 7 days in a week.
Oh, hold on.
Oh, hold on.
We're not working on Saturday and Sunday, man. I need a break. Just like you need a break from school, I need a break from work. So let's try this again. Remember, Chris, we said 1 week was 40 hours. 1 week is 40 hours. And I'm working 4 weeks.
160 hours.
Yeah, because I did my 4 weeks times 40 hours and I get 160 hours. It is super easy to make little mistakes like that because our brains are thinking, oh, there's 7 days in a week. I get it, but we have to stop and pause. What information did our problem already tell us? Make sure you're using the word problems information as you're figuring it out. So now we have our equation, m equals 9h plus 500. So if I put my 1 hour in, how much money do I make? What's my output? James?
$509.
So I put my 1 in, 1 times 9 is 9, 9 plus 500 is 509. Now I work 8 hours. What do I get, Aiden?
72.
Say it again.
72 because you don't get the 5.
Oh, always starting with our base salary. That's our equation. So we have to use the full equation every time. Shh. So if I use that full equation, Aiden, what am I going to get? 572. Because I do 8 times 9 plus 500. So now I'm going to put in 40 hours. And I have to do the full equation. How much money am I going to get if I work 40 hours? Evan?
860.
860. 40 times 9, and then add that to the 500. Now I work 160 hours. How much am I going to get paid, Luca?
$1,040.
Nope. Super close, but not quite. Evelyn?
2,560.
Nope. I want to work your job, but unfortunately, my job's not going to give me that much. Mallory?
1,940.
1,940.
I see that on
Always a good idea to go back and double check your math. Make sure you're plugging in the right numbers. 160 times 9, and then you add 500 to it. So did you get, so are you just checking what the number was?
Yeah.
Okay. Now we have one more problem for this. About how many hours do you need to work to earn enough money to be able to deposit $750 into your savings account? And how many work days is that? Remember, a work day is how many hours? 8 hours. So a work day is 8 hours a day. So how many hours do we need to work to earn enough money to deposit $750 into our savings account? So we want our money to be 750. So just like we did on the last page, we know what the money is, we need to find the hours. So 750 equals 9H plus 500. How do I solve that for the hours? Don't tell me the answer, tell me how to solve it. James?
750 divided by 9 minus 500.
One thing you forgot, James. SADMERP. What do we have to do first in SADMERP? We have to subtract or add. So I'm looking at my opposite operations. I see plus 500, so I need to subtract 500. Now I can do my division. So I'm going to divide by 9. What is 250 divided by 9?
47.77.
Yeah, and here's what I'm going to do, because I want to know hours on the whole. So what is that going to round to?
28.
That's going to round to 28 hours. So if I work 28 hours, how many work days am I going to work? And this can have decimal fraction to it. How many days do I have to work? Michael?
3.5.
3.5. So if I worked 28 hours, I'm going to divide that by my 8-hour days, and I'm going to get 3.5 days. So I work 3.5 days to get, to do 28 hours. 28 hours will give me, is 3.5 days. Do we understand how we did all of that math? So, friends. So let's see how much we have. There is something to be said for working stuff out on your own instead of the teacher telling you how to do it. When we work stuff out and we kind of suffer through it a little bit, we learn from it. So let me just take a peek at what we have left. We have our cell phone, we have our lizard pumpkins, yum, and we have building a floor for your deck. So we have 3 problems left. Here is what we are going to do. Today, your homework is going to do the cell phone. Tomorrow, if you do not get, if some of us are staying after school today to do retakes, because we have retakes we have to do. If you don't have any retakes tomorrow, you can use class time to do the 3rd page, to do those last 2. If you have retakes to do tomorrow, you're gonna do the retakes in class, and that third page is going to be your homework. We will correct that third page on Monday. So tomorrow at the beginning of the class, we will correct the cell phone, so we know if we're on the right track of how we're setting this up. Our work time tomorrow will be doing page 3 or doing our retakes. For my friends at home, we hope you are well. We hope to see you soon.